All right, today we get to combine a couple of things that we have just been talking about. This will be a great review opportunity for us as well as just sort of working with a little more complex problems. We talked about law of sines already. We've talked about law of cosines already. Today we're going to look at a couple examples that combine the two, where you have to use both to get the triangle solved. So I'm just going to start out by drawing a triangle. I am by no means guaranteeing that this is to scale, but they give us angle A is 40.6, they give us side C is 10, and they give us side B is 3.1. So they have in fact given us a side, an angle, and another side in consecutive parts. So this is an SAS problem, which means we're going to have to get our foot in the door at least with law of cosines. Now eventually we're going to have to solve the entire triangle, so law of sines is going to kick in as well. In order to solve the triangle though, of course, I'll need to know 6 things. Some of these things I already am given. I'm going to fill those things in. They tell us what angle A is, they tell us what side C is, they tell us what side B is. It's too bad this is not necessarily a right triangle, or else we could just Pythagorean theorem our way into knowing what side A is, but that's not the case. We're going to have to use law of cosines instead, because law of cosines is just the non-right triangle version of Pythagorean theorem. I'm going to start out with, well, since I don't know side A, I'm going to start out with A as the isolated side in the law of cosines. That's going to equal b squared plus c squared minus 2bc times cosine of the angle letter that you started out with. So we start out with side A, we will close it off with cosine of angle A. And then from here I can just plug in what I know. A squared is, let's see, b squared is 3.1 squared. That's 9.61. C squared, that's 10 squared, that's 100. 2 times B times C is 2 times 3.1 times 10. Well, that's 6.2 times 10, that's 62, times cosine of angle A is cosine of 40.6 degrees. When you grind this all out, 9.61 plus 100 is obviously 109.61. Minus 62 cosine of 40.6. When you grind that all up, you get about 62.54. To isolate the A, you need to get rid of the second power. To get rid of the second power, you apply square root to both sides. The square root of that 62 point whatever gives you about 7.9. I'm going to fill that in here, and now I have all 3 of my sides known. All right, the good news is from here, since I now know a side, Since I now know an angle and the side across from it, I can set up a ratio, or set up a proportion for law of sines. I can say that sine of 40.6 degrees corresponds with the opposite side, 7.9. The way that, for instance, and I'm going to start with, when you're doing this, it's best to start with the largest angles, the longest sides. They'll be across from each other. 10 is longer than 3.1, so I'm going to start by finding the larger angle, angle C. So sine of C corresponds with a length of 10. And from here, if you cross multiply, from this proportion we can say sine of C is going to be 10 times sine of 40.6, all divided by 7.9. So you get some fun little decimal there. Sine of C is about 0.824. Well, then to figure out what C actually is, because right now we have the sine of C, we have the sine of an angle. To figure out that pure angle, you need to get rid of the sine in front of it. And to get rid of the sine in front of it, you apply inverse sine to both sides. So C is going to be the inverse sine of 0.8 0.24, which is about 55.5 degrees. Once you know these two angles, you can simply add them up, subtract the result from 180, you get about, well, 83.9 degrees. And now you've solved the triangle. As a good rule of thumb, start with the largest angle you can possibly start with and work your way down the chain. Let's do another example. Again, I'm going to draw out the information that I'm given. I'm going to draw it up here so I get a little more workspace. So angle X is 23.7 degrees. Measure of Z is 42.9 degrees. And side Z is 14.8 units. And they give us some of this. They tell us angle X is 23.7. They tell us angle Z is 42.9. If we do, well, and side Z is 14.8. You take what you know. Take the 23.7 and the 42.9. That gives you 66.6. We'll take that away from 180. Whatever's left, 113.4, has to be the remaining angle. And now we don't even need law of cosines for this. This is kind of lame, but I guess it makes it a lot easier. We can just use law of sines from here. We can say sine of 42.9 corresponds with 14.8. The way that sine of 113.4, yeah, I'm going to start with a big angle, corresponds with y. If you cross multiply from here, 14.8 times that sine of that angle, divide the result by the sine of 42.9, you get a 20.0 about. So y is about 20. Now, you can't Pythagorean theorem your way into the answer because this is not a right triangle. So you have to now set up another law of sines to get the remaining side. I'm going to keep this sine of 42.9 over 14.8 because that's still true. I'm just going to erase this second part of it. Now I'm going to say that corresponds with sine of 23.7 over side x. If you cross multiply this time, you should get about 8.7. So that's that. I guess the second example you didn't really need to use both. I guess you could have. You could have found x using law of cosines, but most people tend to prefer using law of sines if they can, because it's easier to work with the proportion than it is all those separate terms. No matter how you slice it, though, you should get answers pretty close to this. We'll have a little practice with that, and it should review what we've done the past couple days.